Now, we worked on code that allows us to emit an event when we create a new post. Now, obviously, we're not just creating posts, we're also updating or deleting posts. We want to be able to handle that too. Now, let's do that together and let's continue with updating posts. So on the back end of the feed controller, I'll scroll down to the update post method. And in there, we want to emit an event once we're done updating. So towards the end, once we got our result, we save the post and we're sending a response. Here, I'll again use IO, get IO to get access to our established IO connection, you could say. And I'll again emit on this posts channel, and I'll emit my data, just as before. Now, I will keep my pattern of having an action where I this time write update, because this is the action where you performed. And my post is then my result here, because result turns out to be the result of my saving operation. Now, just as before, I want to be sure that I also have some user data in there. So we'll actually scroll up where we find that post, and I will populate it with my creator data. This again will take that creator ID, which we stored in the post object, reach out to the user's database or the user's collection, fetch the data for that specific user, and add it here in our post. Now I do emit this event where I send my created post. And let's now go back to our frontend application here and also establish some code here to update our post. For this, after this add post function, I'll add a new function, which I'll name update post, where I again get my post data and then I do something with that in the arrow function. And as before, I prepared some code, which we just copy in there, which will add or which will update the post in our list of posts. Now also scroll down in your React code here in the same file to the finish edit handler, because there, where I also have some logic to edit the post, here I will get rid of that. I will actually get rid of this entire part here and also of my update post assignment in this return statement in the set state call, because I now no longer update it here, but I do emit the event to all connected clients, including the client who did, well, send that update, and therefore I can also set up my listener and use that with this new update post function I copied in up there. So let me now go up, and here where I have my established listener for the posts event, I'll add a else if block to see if the action maybe is update if it's not create. In which case I'll call this update post and pass data.post to that. Now before this will work, let me go back to the server-side code, and there, since I do populate my creator when finding that post in the update post function here, this check here will actually fail, where I do check if the ID, which is now not the ID anymore, but the full creator object, is equal to the request user ID. So here, I actually want to access creator._ID toString, right? Because we're populating the creator field with the full user data. It's not just the ID anymore. So we would fail editing this post if we don't make this change. And now if we save both, and we go back and reload both pages, I deleted one post in the meantime, so I only got 2 anymore. And let me now edit this a cup post here, add a couple of exclamation marks maybe, and click accept. And you see it added or being changed on both clients. So this is now also working. Let's start with the status quo. How does our application we built thus far work? And with that, I'm not just referring to the REST API, but to the shop we built before that too. How do typical Node or Node Express applications work like? We got our client, we got our server. The client would be our browser, mobile phone, something like that. The server is, of course, essentially what we built, our Node application. Now, thus far, we always sent a request from the client. We waited for this request on the server. We set up some routes to handle different kinds of requests. And once we're done doing something on the server, for example, reach out to a database, we send back a response to the client. So first request, then response. Now, that is how our application works thus far, and this is how most web applications work. And by the way, we're now not going to replace this with something totally new, which we'll then use all the time. This is a fine pattern because a lot of resources on the internet should be available by this pull approach. So you pull information from the client. You tell the server that you want something. This is a typical approach and this is a fine approach. But sometimes you have a different requirement. What if you want to send something from the server to the client? So what if something happens and you want to inform the client? Let's say you're building a chat application. User A on PC A or on his mobile phone sends a message to user B. Now, obviously, they're not sharing the same device. They might be in two totally different places on the world. Now, user A sends a request to the server that contains the message, and the server stores the message in the database, and the server can return a response to user A. But user B, the person with whom user A chats, does not send a request to the server asking for the message, or at least that is unlikely to happen. You could certainly use some patterns where you send a request every second to see if there are new messages, but you'll then hammer your server with requests where most requests will not yield new messages. So instead, it would be nice to have some push way of informing user B about the new message. And that is exactly the scenario we're looking at here. What if something changed on the server and we actively want to inform a client? Well, then we can use WebSockets instead of HTTP. Now, HTTP is the protocol we used thus far, where we send a request and we get a response. WebSockets build up on HTTP. They are established via HTTP. They use a so-called HTTP handshake to upgrade the HTTP protocol to the WebSockets protocol. And the WebSockets protocol, that simply talks about how data is exchanged, right? So this protocol is something you don't have to manage actively. The browser and the server communicate through a protocol, and the used protocol defines how the communication can happen. With HTTP, it's request response. With WebSockets, it is push data. Or actually, it's both. We can also send data from the client to the server. This is still included. But most importantly, and that is the feature I really want to highlight here, we can push data from the server to the client. And you can, and you typically will, use both together in one and the same Node app. So it's not like you have to decide, do I build an app with WebSockets or do I build one with HTTP? You still have a lot of places where you want to use that request response pattern. For example, if you're sending a message or if you're creating a user. These are operations where you do send some information from the browser to the server. So there, the request response scenario makes perfect sense. But if you have some active notification you want to get to your users, then you also want to integrate WebSockets. Now let me show you how to add WebSockets to your project in the next lectures. Now, for adding WebSockets, you got a broad variety of methods to use. If you Google for Node WebSockets or Node Express WebSockets, you'll find a lot of articles and packages you can use. One of the most popular packages, however, is Socket.io. Socket.io is a package that uses WebSockets and gives you a lot of convenience features around that protocol that make it very easy to set up a WebSocket channel between a client and a server and to use that channel. You can learn all about it here in the official docs. This is no Socket.io course, so I will not cover every single feature it offers. But I will show you how to add it to a project and how to set up some basic communication. So Socket.io is what we'll use. And Socket.io, and that is the key thing I want you to understand, does use the WebSocket technology, the WebSocket protocol, and sets it up behind the scenes for you. You don't have to use Socket.io to use WebSockets though. You could use one of the other options I showed you on Google before. There are packages that give you a more raw approach with less convenience features, and that might be what you're looking for specific operations. We'll go with the convenient solution of Socket.io here though, and I strongly recommend diving into some advanced resources if you want to learn all about WebSockets or Socket.io specifically. So how can we add it to our project now? We want to use Socket.io, and we have to add it on both the server and the client. So both on the Node app here and on the React app, because client and server will communicate through WebSockets, so we have to establish that communication channel on both ends, on the front end, React, and on the back end, Node. Now let's start on the back end here. And for that, I'll quit my development server here, and I will install this socket.io package with npm install -- save socket.io. Let me hit enter here, and this will install the package into our Node project. Now, how do we use it? Well, let's go to app.js, so to the first file that runs when we start our server, and there we should set up our socket.io connections we want to expose. Just as we set up our routes there in the end, we forward requests to our routes. And you could, of course, also do the socket.io setup in a different file, but I'll do it here. But just as we set up our routes for the normal HTTP requests, we can also set up our socket.io channels. And keep in mind, socket.io uses a different protocol, WebSockets, and therefore WebSocket requests will not interfere with the normal HTTP requests, which are sent by default by the browser. So how do we set up socket.io here? Well, once we connect it to our database, when we start up our server, there, I also want to establish, or I want to set up my socket.io connection. I'll create a new constant IO, and I will require the socket.io package here. This package, or the thing we are exporting here, actually exposes a function which requires our created server as an argument. Now, the listen method here does actually return us a new Node server, so we can store that in a constant. This is the Node server we spun up. It's stored here. We have to pass that to the function returned by require socket.io. So we add parentheses here to execute that function that is returned by socket.io, and we pass the server to it. This sets up socket.io, and I mentioned that WebSockets build up on HTTP. Now, since this server here uses HTTP, we use that HTTP server to establish our WebSocket connection that uses that HTTP protocol as a basis, you could say. Now, this gives us an IO, a socket.io object, which does set up all the WebSocket stuff behind the scenes for us, and which we now can use. Now, we can use it to define a couple of event listeners, for example. For example, to wait for new connections, so whenever a new client connects to us. So then we execute a certain function where we get the client, the so-called socket that did connect, as an argument, or the connection as an argument to be precise. So this is the connection between our server and the client which connected. And this function will be executed for every new client that connects. So not only one time, but as often as required, as many clients as connect. So here I will print client connected. And right now, if I run npm start, we'll never see client connected in the console. You don't see it here. Because we established all that on the server side, we now got a waiting socket connection, or port, you could say, but we got no client which would connect. And that, of course, is the next step we have to do. We want to go to our React app, and there I'll quit the development server too. And here I will also install a new package with npm install -- save, and that will be socket.io-client. So it's a different package name. It's socket.io-client because it is the code that will run on the client. Hit enter, and this will install that package into our React project. Now, once this is done, go to the feed.js file in your React project, and there at the top, first of all, import with that front-end import syntax that differs from the back-end syntax, and you can learn more about it in my React course. But there, import open socket. You can name it however you want, but this will be a function that opens a new connection, a new socket. Import open socket from socket.io-client, so from that package you just installed. So this exposes a function on the client too, and this is a function that allows you to connect. Now let's go to that component did mount function here, where we load our first posts and so on. And after we loaded these posts here, after this line, Let's call this open socket function. And now you need to define the URL of the server where you established your socket.io server. And that, of course, is our backend server address. So it's HTTP localhost 8080. Nothing else is required. And please note, you do use HTTP here because WebSockets built up on that. And now this function, which is provided by socket.io, will do all the heavy lifting behind the scenes. And if we now save that and we restart our frontend too, and the backend is running as well, let's wait for that development server to restart so that our application here in the browser will actually reload. And now this should have already executed this open socket code because the page did reload. So if you now go to the backend, you indeed see client connected here, because now we got an established connection between a client and our backend application through socket.io. And all the other normal HTTP requests will still work as before. Now let's use that connection for something useful. And let's see what we could do with that socket.io connection that would make sense in our app here. To be able to reuse one and the same I/O object that manages the same connection that is exposed, let's create a new file. I'll name it socket.js. The name is up to you though. And in that file here, I will create a new variable which I'll name IO. And then I'll export with the Node.js export syntax an object. In that object, I want to have two methods, two functions. The init method, and this is how you define a function in Node.js syntax. You have that key here, like in a normal object, then a colon, and then the value. And the value here is a function which receives the HTTP server as an argument. And in that function body, I'm using an arrow function here, of course. In that function body, you require socket.io. So just as we do it in app.js here, we require socket.io and we pass the server to the function that gets exposed by that exported object or by that exported package. So here, I also execute this function and I pass in that HTTP server I expect to get here as an argument. Now, the result of that is our IO object, which I'll store in that IO variable here. And then I can return IO like this in the init function. In app.js, I can now require /socket, so my own socket.js file, and there I will call init, this function I just defined in there. So this function, I call that. And there I still pass my server, because in that function I expect to get that server. The other code here does not change, it stays the way it is. In socket.js, I now just add another function, so another key value pair in that exported object. So let's add a comma. And then I'll name this getIO. The name is up to you, just as it was for init, by the way. Here I don't expect any arguments, but in that function body, I'll check if IO does not exist. So if this variable is undefined, in which case I'll throw a new error, socket IO not initialized or something like that. If I make it past this if check, I know that IO has been initialized, and then I will just return it. Now with this, we're managing the connection in this file, and we can import this file in all the places of our app where we need to be able to interact with IO, like our feed.js controller. So let's continue with that next. By the way, if you're wondering why there is no name being displayed, I have a bug on my backend code here. In get posts, we should add populate creator to not just fetch the creator ID, but the full object for that creator. And on create post, well, there we have the issue that the post I'm sending through socket.io is just a post object where I did add my creator ID, but not all the creator data. Now, how can we fix that, or how can we add more data? Well, we can send the entire post underscore doc data, so all the data about the post, but set the creator equal to an object where we do have the underscore ID, that will be our request user ID, but where I also then add my name field, which will be user.name. And user.name can be used because we're fetching the user here, and that will be an object which also has a name. So that's just a little tweak we want to add here to send all the data with a created post that we need on the front end. If we now save that and we reload, we get the data because of that change in get posts. And if I now add a new post, another duck, choose a duck, add some content, click accept, we also see the name there. Now both users are named Max, but still keep in mind, the left user we're logged in with is a different user than on the right. And still we get the updates here due to Socket.io. A lot of exciting things were covered in the last modules. REST APIs, async await, and we'll continue on that road. We'll dive into a very exciting technology that you can use in Node applications, Websockets. Websockets are a nice way, a protocol essentially, which allows us to build real-time web services. Now, what exactly does that mean and how does that work? That is what we'll cover in this module. You'll learn why you would want to use real-time web services and what that actually is. And we'll see how we add real-time communication to our Node app, or to any Node app, of course. We'll use a certain library for that, Socket.io, and I will teach you everything you need to know about why to use it, how it works, what you can do with that, and how you use it in your project. So now we also manage updating via Socket.io. There's one tiny thing you might be wondering about. If we create a new post, like a duck again, where I add the image and some content, it does show up at the top, but once I reload, it's actually at the bottom of the list. Well, this is simply due to how I sort on the backend. When I get all posts here in a Feed.js controller, get posts, there we simply have to sort by created at date in a descending way. And now by doing that, if I reload on the front end, our latest posts come first there too. So that's just some tiny cosmetics which better align with the rest of our application, of course. It doesn't affect the way we use Socket.io though, of course. We're now using Socket.io to successfully update and create posts. Now let's of course also align the deletion of posts. And for that, let's first of all go back to the backend code, to the feed controller, and find our delete post method here. There it is. Now, just as before, I want to emit an event once we're done deleting. So I will do that right before I send my response here, let's say. I will use IO, get IO to get that connection, and then I will emit to the posts channel, and I will keep my pattern of defining what happened to my posts inside of the data package I'm emitting. So in here, I'll add my action, which I'll name delete, or where I have a value of delete, I should say. And then my post field here is just the post ID, written like that, which in this delete post function I am extracting up there. So I'm passing that ID through that event I'm now emitting through Socket.io. That is what happens on the backend. Now let's move on to the front end, to the React code, of course. And there, just as before, we want to do something when we deleted a post, and I'll keep it simple. I'll simply reload the page here. You could, of course, implement some code here that simply finds that post, that changed, and just deletes it, but I'll keep it relatively simple and just load the entire page. If we scroll down a little bit to the delete post handler here, we can therefore also comment out this code and instead just call this load posts to reload, not the page, but reload the posts, essentially. This will make sure that pagination also is considered correctly. And now if I scroll up again to component.mount, where I have my other listeners for Socket.io, I'll check if the data action might be delete, which is the latest action we're emitting on the server. And then I will just call this load posts to basically load all posts again. Now this is my front-end code. And now if I go back to my application and I do delete another duck here, it reloads and it also reloaded the posts on the other page, as you see. So now we're also orchestrating deletion to happen across multiple clients through Socket.io. So in this module, we had a closer look at Socket.io, and I hope it became clear what you can do with it. You can push information from the server to the client through that emit method provided by Socket.io. And I also mentioned that Socket.io is not the only way of implementing WebSockets, because behind the scenes, it's that WebSockets protocol that allows you to push data from the server to a connected client. Socket.io just makes using that WebSocket protocol, that technology, particularly easy, and therefore it's a very popular package. Definitely dive into the official docs of Socket.io to learn all about the different features it offers and what you can do with it, because it's a very powerful library, gives you a lot of cool features. So definitely check out the official docs to learn more about it. And of course, also have a look at the other implementations you might be able to use. I just want you to be aware that WebSockets are something that build up on HTTP. You establish them, as you'd see in our application, as a HTTP handshake. So you need a running HTTP server, either set up with just Node.js or a package like Express. And you then use that server to establish a socket, a WebSocket connection on top of that. So both run simultaneously. And as you see in our example app, we actually got both going on. We got normal requests, so to say, and we take advantage of Socket.io as well. So this is an exciting piece of technology that might be interesting for your next application too, and I hope that this module provided a nice introduction to it. If we have a look at our application here, what could we do in real time? Well, what would be interesting is that if we create a new post with user A, that we can instantly see it with user B too. And for that, we need to add some code in our client and then also on our backend. Now, let's actually start with the client. Let's say we want to react to a new post being created, and we then want to render it in the client instantly. For this, in my React app, after this component.mount function, before load post, let's say, I'll add a new function, add post. With this syntax, I expect to get the data about the post as an argument. So I'm using a normal arrow function here. And in here, I want to render that post to the screen. Now for that, since this is not a React course, I prepared some code which you find attached to this video. Just copy it here. In this code snippet, we're using some React functionality, setState, to basically update our existing data we used in this React application with this new post we received here. And I will also take care about pagination to insert this post in the right place. That is in the end what I'm doing here. The important thing is that I'm using some React functionality here so that we don't have to reload the browser page. I simply change the existing DOM. This is what React will do for me with this code snippet. And as mentioned before, if you want to learn more about React, dive into some dedicated React resources, of course. Now we got add post, but we're never calling it. My idea is that I want to call it whenever we do create a new post on some other client. Now, how do we do that? Well, for that, let's go back to the node code. We have to go to the place that runs, or to the code that runs when a new post is created. And that would be in the feed controller, the create post function, of course. There, we want to use Socket.io, the existing connection we have set up, to basically inform all connected clients about the new post. That is the idea. Now, for that, however, we need to share that connection, which we currently set up in app.js. How do we get that connection out of app.js into feed.js now? Let's do that and continue with the setup in the next lectures. Now that we have a way of sharing our I/O connection across multiple files, let's go ahead and in feed.js in our controller on the backend, there, I want to use that IO or that socket.js file. So here, maybe above my other imports, I'll add a new import and I'll name that IO. The name is up to you though. And I will require dots going up one level and then /socket. So this file we just created, I will require that object therefore. And there I can now call getIO to get my existing IO object, which I do initialize first in app.js, right? We initialize it here, so this will be initialized by the time we use it here. So now, this is how I import it here in feed.js. Now inside of create post, I now want to use that. And of course, in create post, I want to use it once I'm done creating the post, essentially. So right before I send my response back, and that response will go back to the user who created the post. Will not change this, we have to send back a response. But now I want to inform all other users. And for that, I can use IO. And there, I can call getIO to get my established IO object or connection we set up in app.js. And now there are a couple of helpful methods the socket IO package gives you. One of them is emit. There also would be broadcast. The difference is that emit will now send a message to all connected users. Broadcast sends it to all users except for the one from which this request was sent. Now I will actually go with all users with emit. Then you define an event name, and that name is totally up to you. I'll name it posts. And I'll define the data I want to send. This is also up to you. Typically, it's a JavaScript object. And here I'll send an object with any data you want. I'll define an action key to inform the clients what happened. The channel, you could say, is posts, but the action now is create. And that is just one way of implementing this, of course. And then the post that was created will be stored in, let's say, a post key. And that is the post which we do save here. So I'm sending this post object in this data package on this posts channel, you could say. Now with that, we're sending this to all connected clients. In the next step, we'll have to adjust our client-side code to also react to such incoming events. And for that, I'll go back to my client-side code. And here, in component.mount in the feed.js file, I want to set up the code to listen to incoming data from socket.io. Because in my app, the events I broadcast or I emit on the server happen to be related to posts, which I manage in the feed.js file in the end. So here is where I'm interested in, well, changes to that. So in component.mount, after opening my socket, I will actually store something which is returned by OpenSocket, and that is my socket. So the socket, the connection which was opened, I'll store that in a constant named socket. The name is up to you. And now on that socket, we can use the on method to listen to certain events. And now here we want to use that same event name we used on the backend. So there I used posts, and if you used something different, you now have to change that in your front end too. So I use posts, and in the front end I therefore listen to the posts event. And there we'll get some data. Now I know that due to the setup I chose here, my object which I send on the backend will have an action key that defines what happened to posts. But that's just the pattern I established here. That is not enforced by socket.io. You can send any data you want here. You don't have to have an action key. I want that though, because I'll actually send different events or different kinds of operations on posts through the same channel eventually. So here I'll have my data object, and I can check data action and see if that is equal to create, which in my case it will be for that event I'm emitting on the backend. And then I want to call this add post, so this function we created before, and I'll pass data post, because again, I'm creating this whole setup, and I know that on the backend, that data package I'm sending through socket.io will have a post key with the post that was created. So that is the post which I will send to add post, which will be rendered by that code then. And that is it for now. Let's save that and also save all your backend code and go back to the application. And now to see that in action, I'll actually fake to have a second client. So I will actually open a different browser, Firefox. And this is essentially the same as if it would run on a different PC now. So these two browsers are now like two different machines. And you can tell by the fact that I'm not logged in here on Firefox. Got a little display back here, but we can ignore that for now. So let's use, let's say, the test2 user. Create a different user if you don't have one. And now I'm logged in on Firefox on the left and on Chrome on the right. Now, on Chrome, this is the test user. On the left, it's the test2 at test.com user named Max. Now let me create a new post here. I'll name that a duck and choose that duck image here and click accept. And you see it to show up on the left too. You also see it show up on the right 2 times, simply because there I also get informed about this created post through my socket, because I'm not filtering to not send this to the client who sent the request. And since I also have some code for rendering the post in my finish added handler in the feed.js file, if you scroll down a little bit, here the post will show up there as well. To prevent this from happening, I can remove this else if case. If I now save this, all the pages will automatically reload. And now let's try this again. A cup. Let's choose that cup image. Accept. And you see it show up on the left side too. And that is the interesting thing. I never reloaded the page on the left, and still we see the new post show up there. That is simply due to Socket.io, where we have an established connection on both clients now, and therefore it also updates on the left or adds this item on the left due to the code we added in our front end.